Hello good day viewers. In this tutorial we are going to find a solution to these three problems that are all related to modular arithmetics. But before we start, I think I have to explain what this modular arithmetics is all about. Modular arithmetics is a remainder arithmetic, so we are concerned with the remainder, and that remainder, the highest it could ever attain is 1 less than the mode itself. Let me give you an example before we start. Suppose this is a clock. You know, this is 12, this is 6, this is 3, this is 9, and suppose it is pointing exactly 9. You should know that clock is either a mode 12 or 24. It doesn't matter because 24 is a multiple of 12. So now that we are at 9 o'clock, if I should add 6 hours from this 9, we are going to get to 3 because, you know, this is 10, this is 11, this is 1, this is 2. So we have 1, 2, 3, 4, 5, 6. So instead of 15, we have 3 because we are a mode 12. Whenever you get to 12, you have to recount all over again from 0, 1, 2, 3 in that order. So we have 1, 2, 3. We have completed the bundle, which is 12. Therefore, we have to complete that 6 that we have started counting. 1, 2, 3, and we get to this. And what about if we should add 12? From 9, if you should add 12, you will have to come back to that 9. This means that adding 12 to any number in mode 12 is just like adding 0. What if we should add 24? 24 is also a multiple of 12, so it's like we have not added anything. But what if we should add 25? Remember, we are concerned with the remainder. So if you add 12, it will go back and come back to 9. Add another 12, it will go back and come back to 9, making 24. But we are talking about 25. We have 1 extra, so this, our hand will look at 10 exactly. So if you should add 25, it will become 10 o'clock. This means that if you should divide that 25 by 24, you have to get 1 with a remainder of 1, and you have to add that 1 extra, which is going to make it 10. So now let us consider these three problems. The first one, we have that 17 is equivalent to a certain number, but in mode 5. What does this mean? It means that we are now talking about bundles of 5. 1, 2, 3, 4, 5. You recount all over again. 1, 2, 3. All the countings will be based on 5, which is a complete bundle. So 17, how many bundles of 5 are there in 17? We have 3 groups. Or let me say we have 3 bundles with a remainder of 2. So this number right here is just our remainder. What does this mean? It means that if we should divide 17 by 5, what is going to be the remainder? And that remainder is going to be our solution. So this time around, you can even do it practically. You say 5 plus 5 plus 5, since we are counting in bundles of 5. This is 15, then plus 2. Can you see? This is complete bundle where we have a remainder of 2, and therefore this x is equivalent to 2. And another way you can do that is to say that this 17 divided by 5 is equal to 3 with a remainder of 2, and therefore x is equal to 2, but only in mode 5. Okay, second question, we have that 5x is equivalent to 8. This time around, this 8 is our remainder. So how many bundles of 6 are there in such a way that the remainder will be 8? So we have that 5x is equivalent to 8, but in mode 6. Remember I told you that the highest we can have is 1 less than the mode itself, but this time around we have 8. We can reduce this to 2. It's the same thing. So we have 5x equivalent to 2 in mode 6. Because if you divide this by 6, you're going to get 1 with a remainder of 2. So this and this means the same thing. But it doesn't matter. We're going to arrive at this 8 again, because we are going to add multiple of 6 to this number until it gets to a number that is divisible by 5. Because we cannot just say divide both sides by 2 the way we normally do in linear algebra because it is going to give us a fraction here, but we are concerned with positive integers. So this is equivalent to 5x, which is equivalent to 6 plus 2, which is 8. You see, we have come back to what we have earlier, mod 6. But again, this is not divisible by this. So we can add again, it's just like adding 0. Complete bundle is the same thing as 0. This is equivalent to 8 plus 6. Again, this is 14. Mod 6. Again, this is not divisible by this. We continue adding 5x. I want to do it practically. I know I can just add it directly. I can add that number directly to this so that it will be divisible by 5. But I just want to show you the steps. This plus this is now going to give us 20. Mod 6. But now that 20 is divisible by 5, we can conclude that this x is equal to 20 divided by 5, which is equal to 4. Therefore, the value of x is equal to 4. And we can test it here. 5 times 4 is 20. And how many groups of 6 are present in 20? We have 3 groups because 6 plus 6, 12 plus 12 is 18. But 18 is 2 less than 20, so we have a remainder of 2, which satisfies the equation. Therefore, the value of x is equal to 4. Let us take the last one. The last problem, we have that 5y plus 3 is equivalent to 2, but in mod 11. Let us first of all take this term here. We have that 5x, or let me say 5y, is equivalent to negative 1 because 2 minus 3 is negative 1 in mod 11. We're going to repeat the same process. We're going to add multiple of 11 to this number until it gets to a certain value which is divisible by 5. So this 5y is also equivalent to 11 plus negative 1 is going to give us 10. In mod 11, let's stop here because 10 is divisible by 5. Therefore, we can say that 5 is equal to 10 divided by 5. And this is equal to 2. It means that the value of y is equal to 2. Let's see whether this is true. So if y is 2, we have that 5 times 2 is 10, and 10 plus 3 is 13. How many groups of 11 are there in 13? We have only one, 11, and from 11, 12, 13. We have 2 remainder, which is this. Therefore, y equal to 2 satisfies this equation, and hence we say that y is equal to 2 is our valid solution. And this is all I have for you today. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.